Wir haben ja auch diese Roboter konnten wir selber gestalten, wie die aussehen.
We were able to design the robots ourselves, how they look and so on, and I really enjoyed that. And when you see it running about and playing music and looking so nice, that's really good.
Robotics offers untold opportunities for dispelling the old prejudices about women and technology.
In der Industrialisierung ist es so gewesen, dass
In the age of industrialization, an amazing number of women were active as inventors. It was just never publicized, because women back then weren't allowed to take out patents. It's only since then that research has revealed how very many everyday objects like washing machines were originally devised by women and developed into commercial products. I can well imagine that women will contribute to the development of a somewhat different sort of technology in future, perhaps one that meets the everyday needs of us human beings more directly than the technology that we men alone are capable of producing.
A training session shortly before the Robot Soccer Championships in the Fraunhofer Institute for Autonomous Intelligent Systems. The tension is evident only in the trainers, students on the Autonomous Systems Master's course at the Rhein-Sieg College, like 25-year-old Florian Adolf. His team seems perfectly composed, soccer robots based on the agile Volksbot. They've no fitness problems and are in good condition, but they still need training in their attacking maneuvers and the accuracy of their ball control. Under the guidance of the Fraunhofer scientists, these soccer robots are ideal for training future mechatronics engineers.
My background is computer science, which still leans towards theory. You get as far as software and that's it. Integrating software with the real world is a huge step. It has to be fast and robust because the robots have to function autonomously. Everything has to be predictable, solid and fast from the outset.
Is it about,
Theory and teaching in close relation to application. It's almost child's play for Florian and his fellow students to acquire the basic knowledge and the latest research findings at Fraunhofer AIS for practical and competitive purposes. Like the RoboCup German Open in Paderborn, every year thousands of fans and scientists follow the German championships organized by Fraunhofer AIS, where leading robotics institutes from around the world compete. The RoboCup has become an internationally recognized standard test and benchmark of the artificial intelligence of cooperating robots. Fraunhofer AIS has entered Florian Adolf and his fellow students for the competition, the acid test in practice, and not only for their Volksbots.
There's a difference between reading a paper on something or really having to try and make it work, apart from all the stress of getting everything ready within an hour, synchronizing 5 robot players, seeing that the software's okay, putting the finishing touches to the robots. It's quite hectic. It's a completely different form of scientific work because it really is applied science.
The standards are raised every year. The level of the RoboCup is set higher and higher. It's become a matter of honor for Fraunhofer AIS to equip its soccer robots with only the most advanced components, which are intended for applications in manufacturing and service industries. Tested in practice on the football pitch, concentrating on the market.
The concentration
is simply that many of the components we've introduced have been reduced to the minimum, to what's absolutely essential, the profile system, so we can add on other sensors flexibly in modular fashion. Different sensors and actuators have become possible. The computing power has been transferred to a laptop, which can be used universally beyond the Volksbot as well.
All this has made possible an inexpensive robot platform not only for training purposes, which pursues its goal autonomously, avoids all obstacles and can therefore be developed into a service robot with various characteristics and functions.
Die gesamte Plattform ist in seiner...
In its value for money, the whole platform has come so close to being a product in its own right that further applications are now possible. Autonomous lawn mowers, for example, or vacuum cleaners, or transport assistants in the widest sense, sensor data carriers. In other words, all the applications we're familiar with from this kind of mobile robotics.
Despite their differing applications, autonomous robots have a lot of features in common. That's why Fraunhofer AIS has followed the successful strategy of developing modular robotic components that can be built into its robots according to their use. AIS Vision, for example, is a camera sensor with 360-degree all-round vision for image processing in real time. Its new mirror overcomes all the problems earlier solutions had with scattered light and reflections. Image processing is controlled by innovative software, which enables the camera to devote more attention to significant picture segments, like the movement of the ball rather than the feet of the referee, for instance. Development costs are reduced by the Fraunhofer DD-Sim simulation software. Here, for instance, by ensuring the robot soccer teams are properly coordinated before they begin. The simulation tool significantly shortens the development time for behavioral programs for robots by drastically reducing the number of practical experiments necessary. The user can easily simulate all the influences on the robot's behavior in advance of real trials. Alongside the software, Fraunhofer AIS also produces the hardware components for its robotic modules in its own laboratories. Here, chips are being mounted on a printed circuit board to produce a 16-bit motor controller. The motor controller's task is to transmit human software commands or incoming sensor information to the robot's drive motors. It ensures fast and flexible reactions and at the same time smooth movements on the part of the robot, with low torque fluctuation even when several direct current motors are working in parallel. The motor controller has to transmit every command for avoiding obstacles to the robot drive instantly and with absolute precision, even at the Volksbot's maximum speed of 3 meters per second. The motor controller also checks the operating temperature of the motors and helps the robot monitor its own position by measuring the motor revs and calculating precise movements from them. All this makes the Volksbot a dependable service robot. High-tech sensor technology, robustness, functionality, and outstanding mobility are essentials for autonomous robots. But these characteristics alone don't determine how efficiently the robot works in the service of man. The robots of the future must also be intelligent, must be able to use incoming sensor information and stored knowledge to make the right decisions and learn from their experience.
Intelligenz bei Robotern spielt genau da eine Rolle, wo Roboter in unbekannte Umgebungen.
Robots need intelligence when they find themselves in unfamiliar surroundings, in environments that can't be described in detail in advance. This is where my vision of robots differs strongly from that of the standard industrial robotics implemented these days, where both the environment and the robot's task are clearly defined. I'm thinking of exploratory robotics and of robots helping us humans in our daily lives. For that, you need intelligence.
Classic artificial intelligence functions by means of one-dimensional knowledge transfer. But to produce the complex behavior of living creatures, we must learn from the biological brain, the complexity of which results largely from countless oscillators consisting of neuron groupings with feedback capability. Neural networks for controlling movement can integrate amazing functions even in the artificial microbrain of a basic TED mobile robot with its simple chip structure. TED's neural network is linked to its sensor technology so that it can autonomously move towards light sources, for instance. This sort of ability will enable robots to recharge their power supply autonomously via solar cells. Following nature's model, neural networks can also be incorporated in multiped robots capable of operating in unknown environments, a useful ability for exploring other planets or for searching for people buried under rubble in earthquakes. Amos and Morpheus can get through their obstacle course completely autonomously. Many tasks can be successfully performed only in groups. Swarm robots, equipped with neural networks, exhibit autonomous behavior for the purpose of collectively performing tasks. Swarm robots follow three basic rules. They avoid obstacles and collisions, they move at the same speed as one another, and they jointly pursue a goal. Here, moving into a pool of light to recharge their energy supply through their own solar collectors. Full of energy again, they swarm out to fulfill their actual team task, cleaning large buildings, for example, or mowing large areas of grass. A new generation of robots opening up a wealth of possibilities.
These
robots have the potential to operate intelligently on their own, in the sense of making the best use of resources, providing exactly the right sort of support, being good partners and assistants to human beings. This is a future that's really wide open, and we've only just begun to take the first steps.
A major step in this direction is being made by the Fraunhofer Institute for Autonomous Intelligent Systems itself, with its aim of bringing together various disciplines that otherwise develop independently of one another, such as computer science, electronics and mechanics, and fusing them into a future-oriented system technology which combines all available scientific and technical know-how in order to help promote and preserve mankind's prosperity.